motivational speech.
It's on A1 like that.
I changed the top.
Oh, okay, sorry, I look. You all begin recording already? Okay, so record directly into the iPad. Okay, thank you. Okay, so let's go through the other parts. Okay, I'll only run through if you find that the drawing, your drawing is different, but you want to check if it's okay to join that way. Right? Then I'll go through it. Yeah.
I want the line like this. It looks like smooth, then the line is very nice.
Cannot. Do your best to draw a smooth line. Okay? Yes. Don't need a perfect circle, but just look like something like a circle can up. Don't give me something like that. Don't like that.
Yeah, mine.
Yeah.
Are you sure or not?
Yeah, no, I need to see some effort. I hope we're on the same page when we talk about effort. Okay. So, have you done helium yet? Okay, if you have something different you want to check, let me know. Okay, so for example, let's look at beryllium. Let's say you do it this way. Your first circle, your electrons are like that. Then the second circle, your electrons are like that. This is okay also. That's okay. Okay, boron and carbon. Can I move on? Yes. Okay, so Valentina, the outer circle, must it be like that? 1, 2, 3, or can you spread it out a little bit more? Is that your question? So for example, can you spread it out like that? 1, 2, 3. Okay, you can spread out. How yeah? Yeah, you can spread it out. Okay, next two. Nitrogen and oxygen. Yes.
Without mark, if we put nitrogen on top.
I don't understand your question.
I put 8N on top, so 8P below.
Oh, you mean what? For oxygen or nitrogen? For this one? You put what? I know the nucleus. What do you put inside?
I put N on top.
Oh, it's okay lah. It's okay. Yeah. Yes?
Is this a
What is this?
Henry's drawing?
Why can't you describe it?
This.
Pass me.
I think it's okay.
Yeah, this is unbelievable actually.
It's the work of art.
Oh. Okay. What is Henry asking? Henry is asking if your circle can be like that. No. Okay? Draw. When you draw, be diligent. Connect things together. This is not how I taught you how to draw, remember? I know this is not biological drawing, but draw it properly. So put in some effort to connect it. Okay?
The shape
So the circle cannot be hairy.
No, cannot be hairy.
that is the Harry.
If not, I will make sure when I give you a zero, right, I will make it very nice zero also.
Wow.
Yeah, I'll make it connect.
Okay.
Being recorded, I keep forgetting. Okay. chlorine and neon. Okay, moving on. Hey, you stop me if I'm too fast, huh? Sodium and magnesium. How's this topic? Are you enjoying it so far? Quite doable?
Not enjoying, but
Okay, not enjoyable, but it's logical, doable. Yeah, with some practice, I think it's quite manageable for this topic. Okay, moving on. Aluminium and silicon. Okay, are there aluminium and silicon? Phosphorus and sulfur. Chlorine and argon. Yeah.
so if we cluster like all 8 of the electrons together,
Yeah.
have you spread it out like 8 individual?
No, there will be some pairing. Yeah. Okay, finally, potassium and calcium. Potassium and calcium. Oh, okay. I think calcium and potassium will be the max if we will go. Okay? So, yeah, potassium and calcium will be the max that we will go. You have to memorize this. You don't have to. It is an understanding. You know the skill of it. All you have to do is to look at the periodic table. You can figure things out. Okay? It's a skill. You don't have to memorize. Okay, I would like to collect this. Okay, because I want to see how you draw. Okay? Then I see how you think you fare. Okay, so can you pass your scripts to the front? Then Melanie, what were you doing just now? What were you doing just now during lesson?
So like the actual cheats.
Okay, come, can you correct it? Okay, then you can stand by your textbooks. You're going to complete this segment of the lesson. What? Writing is dangerous. Okay, tomorrow morning, everyone take out your textbooks. We're going to resume lesson. After this is LA. I think I've seen this every week, right? Recess. Or recess. Yeah? Did I say that? What do you mean I'm gone through practical in class? Yeah, I say I'll do that. Now what was last night for? What's for the knowledge cafe for? Then last week I went through practical already, so that's not what's happening today. Yeah. Also I put out the schedule for this week. Yeah. Okay. Go and stand outside for a while. You literally just want to stand outside. Go and stand outside. Thank you. Do you know where's the textbook? Do you need to stand outside also? Okay, please stand outside. Yeah? It's fine. Yes, very good, Hao Yang. Yes.
So today is practical exam, so just let us revise.
I agree on that. That's not how it goes.
But that's what our other
No? You are mentally prepared. You are ready.
Lesson given like 5 years to write.
Yeah.
Teach Chinese. You start memorizing the periodic table.
Sorry?
Memorizing the periodic table.
No, you do not need to memorize the periodic table. When it comes to your quizzes or exams, we will provide you a periodic table.
Wow.
Okay, so you don't need to memorize that. No point.
So you can have we will have a tutor.
Sorry? Yes, you will be provided a periodic table to do your questions. Hey, the clock is off, is it?
No, it's 7. It's not your class yet. Actually, only the time loop.
Yeah. We are in a time loop. Okay. Next part of our lesson, we are on page. Okay, come flip your page to page 60. Okay, we are beginning on page 66 of your textbook. We are going to the periodic table. Okay, for today, we're going to introduce you to the periodic table. There are a lot of information in the periodic table that's given to you. Some of the information has been, we talked about it last week. So for example, let's look at your textbook. You look at a textbook on the left side, the bottom part, and then they show you carbon and they give you a lot of blanks. Okay, they give you a lot of blanks. What do those blanks represent? You can find this information in your text at the back of your book, where you look at a periodic table to understand what those different components represent. Okay, so let's revise. The number at the very top of carbon, okay, carbon looks something like that. It's a 6, a C, and then you'll write carbon, and then you'll write 12.0. Okay, a quick revision. What do the different points represent? 6 on the top. This is the the atomic number? Everyone have a think? And then I'll ask someone to reply. Atomic number, what does the atomic number tell you? Okay, what does the atomic number tell you? How many presence of how many what? Okay, so what does the atomic number tell you? Xavier? So carbon has atomic number of 6. What does it tell you as how many what? How many protons? Okay, so it tells you the number of protons. Oh, and it can also tell you the number of electrons. That's possible. Okay, it can also tell you the number of electrons. This is the chemical symbol. This is not something we would, so we don't have to write the full name of carbon out very often. Just write C will do and we know it's carbon. 12.0. What is 12.0 called? Sorry, easy. It is the relative atomic mass. What does relative atomic mass represent? Why is there a decimal place? Can you recall from last week? What is nucleon number, is it? Okay. You notice we don't see it here? Okay. You would find nucleon number if I provide you it in this form. So for example, 12 and then 6. Yeah? This will be the atomic number. This will be the mass number or the nucleon number. But notice that the way we write this is different from what you see in your periodic table. Why do we write it differently? It's different because when you write it this way, you're writing the symbol for specific isotopes. There are many different isotopes of carbon. For example, there's a carbon with 7 neutrons. This is carbon 13, and then there's carbon 12. The decimal place we see here is because we're getting an average of the mass numbers. Okay, we're getting the average of the mass numbers. Okay, so that's why it's different. When you look at your periodic table, it's different from how we would write the chemical symbol. The chemical symbol represents individual isotopes. The periodic table shows you the average of the isotope, the mass number. Yes, Haya?
Will the relative atomic mass always have the same full number as the mass number?
No, it does not. Okay, it really depends on the proportion of the isotope present on Earth. Okay, an example would be if you look at chlorine. In chlorine, you look at the mass number, the relative atomic mass, it shows 35.5. It shows you 35.5. But that's not what the mass number of individual chlorine atoms are. There are different chlorine atoms, and then if you take average, you get something with a decimal point. Yes?
Then if you want to find the one of okay, just like round off the relative atomic mass.
If you want to find this one, can you just round it off, is it? No, that's not the way to go, because it does not, we really cannot tell if this is equals to one of the mass numbers of the isotopes. Cannot tell. Yeah, we cannot tell. Okay, so now some new terminologies are introduced for periodic table. You notice if you look at your periodic table at the back, there are rows and there are columns. Okay, have a look. There are rows and there are columns. We're going to try to make sense of why scientists organize the elements in this way, in rows and in columns. Okay, why did scientists arrange everything in rows and columns? Does this serve any purpose, or did we arrange it this way just for fun? Okay, so some things you could label on your periodic table. We call the rows periods. Yes, Henry? Okay, we call it periods. We call the columns groups. Okay, so you could label your periodic table now. How many groups are there from your periodic table that you can see? Yeah, how you?
Is period like the first row period 1, second row period 2, or is it just like this one is 1 period, that one is 1 period?
That's a great question. So hydrogen and helium, that's period 1. And then we go on to period 2 and period 3.
It's a fixed period.
Sorry?
So if you say period 1, you will always need hydrogen and helium.
Yes, correct. Okay. So how many groups are there if you look at this periodic table? Give a quick count. How many groups are there or how many columns are there? Remember, groups are the columns, not the rows. How many groups do you find in the periodic table? Okay. 18 groups. Can you see 18 groups in your periodic table? How many periods are there?
1, 2, 3, 4, 5, 6, 7, 8.
Okay, I'd like you to ignore the 2 rows on the bottom. You can ignore those 2 rows. How many periods do you see? Okay, you should see 7 periods. You see 7 periods. And you see 18 groups. Yeah?
How come the last 2 elements like got spacing between?
Oh, over here? Oh, that's a great question. I'm not too sure why. It could be that we've left some blanks so that we can fill in new elements that we found later on. Okay, so first 2 things that we are learning about the periodic table. There are rows and there are columns. And they are called periods or groups. Okay. So why do we arrange all the elements in this way? Okay. First thing I'd like you to take note of is this. You look at how the elements are arranged. Notice we arrange it from left to right in ascending atomic number. Can you see that? It goes from 1, 2. And then the second period, 3, 4, 5, 6, 7, 8, 9, 10 is ascending atomic number. Yeah? So periods, we arrange it ascending atomic number from left to right. This is very useful. So if you want to find information very fast, you can count. And you can find the relevant atomic number. So it's not arranged according to alphabetical order. It's arranged according to atomic number.
Isn't it like also like metal, metallic?
Okay, we'll come to that after this. Okay. Another interesting thing about how we arrange elements in the same period. Okay, I'd like you to just quickly tell me, for hydrogen and helium, how many electron shells are there? In hydrogen and helium, how many electron shells do you find in hydrogen and helium? Period 1. Okay, let's look at hydrogen and helium. Can you tell me what is the simple electronic simple electronic configuration? The simple electronic configuration is this thing, is the 2, 8, so that one. So what's the simple electronic configuration of hydrogen? Jaden? 1. Just 1? Just 1. Helium. What would helium be? Tyson? What's the simple electronic configuration for helium? How many electrons? How many shells would you take? So quick practice. Just 2? Just 2. How many shells are there? 1? Yeah, 1 shell, right? Okay, so hydrogen 1 shell takes up only 1 shell, takes up only 1 shell. What? No. Okay, 1 shell only, yes? Go. Okay, only 1 shell. And it corresponds with the period. Okay, period 1, 1 electronic shell. one shell. Do you think this holds true for the other periods in this time? Let's go to period 2. What are some elements in period 2? Let's extract a few. We have lithium, we have beryllium. Let's take one from the opposite end. Let's look at carbon. Everyone have a quick think. What's the simple electronic configuration of these three fellas? Okay, write it down and then I'll just ask a few of you, three of you. Okay, what's the simple electronic configuration of lithium, beryllium, and carbon? Shamin, you want to go wash up? Okay. Ready? Okay, so what's the simple electronic configuration of lithium? It's your 2 1 2 1. Beryllium, Melanie. Sorry? 2 2. Let's go all the way to the other side of the period. Let's look at carbon. Melanie, you can come in. Caleb, what's the simple electronic configuration of carbon? 2 3. Okay, you think about it, huh? 2 6. Okay, it's okay. You go and think about it. Yeah. So what's the simple electronic configuration of carbon? How will you find it out? You look at the number of photons. There are 6. So there are 6 electrons likely. So okay, thank you, Xavier. How many shells does lithium have? 2. How many shells? We have 1, 2 shells. How many shells does beryllium have? 2 shells. 1, 2. How many shells does carbon have? 1, 2. And they are in period 2. So that's the value of the periods. Each period represents the number of electron shells that the element has. Yeah? So if I were to ever ask you, oxygen comes with how many electron shells? Don't need to count anymore. Just go straight to the periodic table, find the period it's in, and you have the answer. Okay, so that's the value of the periodic table. They've arranged it in such a beautiful way. If you don't believe me, we go to period number 3. Let's try just for potassium and calcium. Yeah? 8 row, yeah? Okay, so I was orbital is one way of saying it. Shell is another way of saying it. Now I'll just use shells. I'll use shells from now onwards. Like 8 shells. Okay, so let's go to period 3. Let's see if this still holds. You test it out. Period 3. Let's look at some elements in period 3. Let's look at sodium. Let's look at aluminium. Okay, just sodium and aluminium. Right? Everyone practice again. What's the simple electronic configuration of sodium and aluminium? Okay, everyone practice. Okay, once done, you want to check with your table partner. Okay, what's the simple electronic configuration of sodium and aluminium? Okay. Hui Yi, what's the simple electronic configuration of sodium? 3.1. Sodium. Okay, so for those that want to revise, the first shell maximum you can fit how many electrons? 2. That's the maximum. First shell can maximum fit 2. Second shell maximum fit 8. If you need more space, you can go to the third shell, maximum fit 8. Sodium has how many electrons? It has 11 electrons to work with. So that's how you will start to fill up. So maybe Hui Yi can try. Sorry, 2. Okay, 2, 8, and then 2, 8, 1. Everyone happy with that? Yeah, 2, 8, 1. Okay, good. Yeah, 2, 8, 1. So this is how we will do it. We'll fill it up from the lowest to the highest. So 2, 8, 1. Okay, aluminium. How young you want to say something?
The other day, I like search on Google, right? Then a lot of sources say that like I forgot it's the third or second one. The third or second one can hold 18. Yeah.
Oh, okay. Yeah, so right, it can hold 18. That you will learn in JH3. That's a different model already. Okay, the model we are working with is this particular model. Okay, so you're right. Actually can, but that's not what we're working with. So 281. Okay, so aluminium. Christy? 284. 284. So in total there is 14. Right now, aluminium. 283, okay. 283. Is that what everyone got? 283. So how many shells are there? There's 1 shell, 2 shell, 3 shell. 1 shell, 2 shell, 3 shell. And they are all in period 3. So that's the value of periods. Periods show you the number of electronic shells that a particular element has. Okay? So that's the usefulness of it. Now what's the usefulness of groups? Okay, what's the usefulness of groups? Okay, let's try and find out what's the usefulness of groups now. We see if we can find a trend. Okay, we see if we can find a trend. Let's pick elements from group 1, lithium and sodium. Okay, now I need a few people to try already. Lithium, sodium, beryllium, magnesium. Okay, everyone practice. Write down the simple electronic configuration. The more you practice, the faster you get. Okay, so lithium and sodium. This is in group 1. This is in group 2. Okay, what do we have? Group 3. Group 3 we have boron. We have aluminium. Oh, we've done aluminium before already. Sorry? Oh, I see. Thank you. Oh, group 3, group 13. Group 13. Okay, then after we go on to group 14. Group 14 we have carbon. We have silicon. Okay, so we have quite a few to practice. You give it a try. See how fast you can go now.
Wait, Mr. Tan,
Yeah?
is hydrogen in group 1? Because like the first element.
Oh, that's a good point. You can put it in group 1 if you want to. Yeah, you can. Okay, everyone try. Then we try one more. We go to 17. Group 17. Then we go to fluorine as well as chlorine. Okay, let's see how fast you can go. What's the simple electronic configuration? That's enough for everyone that's not tried today yet. Yes. Then we'll see if we can find anything common. What's the purpose of groups? Okay, some of you look quite ready. So let's go. Henry, what is the simple electronic configuration of lithium? 2.1. Well, okay. Sodium 281. Well, okay. Caleb, beryllium 2.2. Tio what? Okay, Tio. Okay, Caleb come in. Magnesium. Emma? 2.8.2. Okay. Do you see a trend yet? Jaden. Boron. 2.3. George. Aluminium. 2.8.3. Anyone spots a trend yet? Why we group things in the same group?
Is it the last one?
Okay. Sophia. Carbon. 2.4. 2.4. Okay. Cao Yushen. Silicon. 284. Okay. Fluorine. Charmaine. 2 and 7. And last but not least, cadence. Chlorine. 2.8.7. And you all spot the trend. Why do we group things in the same group? Okay? So what trend do you see? Jaden?
The last number is basically
The last number is basically the...
The first and last number is the same as the center.
just the shell.
The only difference is the shells.
Okay.
Shell.
The difference is in the shell, right?
Shell.
Yes.
But what do you find common?
The
The last number, right?
And the first one.
Oh, what do you mean the first one? Oh, and the first one. Okay, but actually you notice the first one will always be the same everywhere, right? We always fill up 2, right?
Oh yeah.
Okay, so 1, group 1. The last shell, 2 electrons, group 2. The last shell, 3 electrons, then you see group 13, 3. The last shell, 4 electrons, 14. The last shell, 7 electrons, the 7 over here. So if you want a quick way to find out how many electrons is in the last shell, you can look at the last number of the group. Yes?
So is hydrogen in column 1 or column
Column 1 or column
8?
8. Okay, so hydrogen has 1 electron in its one shell, right? So we could put it in this group if you want to. Yeah, because it's 1 electron in the last shell. I'm going to introduce one new word to you. The word is called valence.
Wait, is double key not due today?
Sorry? Worksheet not due today.
Oh.
Yeah, I just give it to you so you can start early if you want to. Okay? I'm going to introduce a new term to you. It's called valence electrons. Valence electrons means the number of electrons in the outermost shell. So I could ask you, how many valence electrons does magnesium have? And you would say 2. Magnesium has 2 valence electrons, 2 outermost electrons in the shell. If I were to ask you what's the valence electrons for carbon, you would say, what, have I lost some of you? Okay. How many valence electrons does carbon have? 4. How many valence electrons does chlorine have? 7. Okay, so that's how we go about it. Valence electrons is the number of electrons in the outermost shell. That's what valence electrons is referring to. Question?
Like, does this thing still apply to group 3, 4, 5, 6?
Group 3, 4, 5, 6, is it? Yeah, it still applies. It still applies. So 6 valence electrons, 8 valence electrons still apply. Okay? So if I were to ask you now, some of things we skip, right? Can you just tell me very quickly, how many valence electrons would nitrogen have? And you would say Nitrogen, so look at your periodic table. We didn't go through that period, right? That group. How many valence electrons will it have? Yeah, nitrogen. How many valence electrons will it have? Jen? How many valence electrons would nitrogen have? 5. How many valence electrons would neon have? Nicole Wong? Neon. Neon is in group 18. 8. So, next person. How many valence electrons does phosphorus have? How many valence electrons does phosphorus have? Tyson? Phosphorus. 5. Okay, high 5. How many valence electrons does argon have? Argon. Can you find argon? We have a few more I don't ask. Emily. 8. Okay, so the value of groups, the numbers, is to tell you the number of valence electrons. That's the value of it. You see, you got a question? You see, looks a bit skeptical. Yes. Yeah.
Then you put the last number of group 13, so boron is 2.3. Then what about group 3? Like group 3, 4, 5, 6, right? It just
Okay.
2.3, 4, 5, 6.
Great question. So we can ignore group 3 to 12. Group 3 to 12 is a special group of elements that we're not going to cover. They are called transition metals. Transition metals. This is a group that we will not be delving into. It is not our focus for, I will not. Okay, you'll learn more about transition metals, not sure even when. You're not going to learn it in upper J also, I think maybe university. Okay, so this group of elements are rather special. Their properties are quite unique. Yes?
How about the element below?
Those elements below, even more special. I don't think, I've never learned it before. They are,
Like named after people.
yeah, they're all named after people. If I'm not wrong, this group of elements below in the 2 rows, they are quite radioactive in nature. Okay? They are very hard to exist on Earth. A lot of them are man-made. They created one. Okay? And that's why they are named after specific people. Einsteinium. Okay? And so we've learned a few things today. We've learned the purpose of periods and groups. Now, having this knowledge with you now equips you with the ability to find information very fast. Okay? Periods and groups. Okay, we'll pause for a while. You can talk to your friends. You can take a chill pill, drink some water. Yeah? If you want to clarify anything, now would be a good time to clarify. Go, go. Okay, while your friends are out emptying their bladder, let's listen to some music. Anyone can memorize this entire song? I give you lifetimes of what's the
Also available in zero added sugar, Milo Galcoso.
ねえねえ、アーフェムのランドリーボール買ってきた？洗濯は？16種。
And now, ASAP Science presents the elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air, oxygen, selenium, fluorine for your pretty teeth, neon to light up the sign, sodium for salty times,
Magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, and argon,
potassium,
calcium, so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is periodic helium and beryllium, platinum, gold to make you rich till you grow old. Mercury to tell you when it's really cold. Barium and lead is it for your tummy. Polonium, acetine, cadmium, radon, and cesium will last a little time. Radium, then actinize it. Analysis, periodic table, noble gases stable, elements and alkali reactor recipe. Thank you guys so much for watching.
You can sing this song from top to end. I'll buy you a movie ticket. Really, legit. If you can remember, I don't think it's, I don't know how you can do it.
What's this?
So I won't play again.
You like the song?
Okay, I will not be seeing you this Friday, right? Because of Good Friday.
Yes, Friday.
Okay, so to end off today's lesson, I'm going to share with you the name of this last group of elements. Okay, can you tell me the elements in this particular group, starting from the top? Helium?
What?
Wait, no.
Group 18, huh? Neon? Argon? Anything else? Krypton?
Kryptonite.
Well, I like that. Is it KR?
Yeah.
Okay, anything else?
Xenon.
Xenon?
Radon.
Radon. How's it spelled? R?
Radion.
Just RA? RN.
Yeah.
Okay, is that all? Okay. What's common about their electronic configuration?
What?
Maybe we stop here. Okay, let's look at from here to argon. Okay, here's these three. What's the simple electronic configuration of He?
Except for helium.
2. Thank you. What is neon? 2, 8. What about argon? 2, 8, 8. We call these elements in this row, in this column, the noble gases. They are called noble gases because they are gases. Noble, I don't know why it's called noble gases. But you notice one very special thing about all these gases is that their electronic shells are completely filled. Right? Every shell is maxed out, right? Helium, 1 shell, I max it out. Neon, 2 shells, I max it out. Argon, 3 shells, I max it out.
Wait, so does that mean that the fourth shell is maxed out for?
Yeah, if I were logically, if I were to go on to the next one, the 4th shell maxed out.
Wait, so the fourth shell can contain up to 8?
I don't know, does the math make sense?
Yeah.
Okay, yeah.
It's 8, and then
Yeah. Okay, so but I'll just stop here. Just stop at argon. One unique property about noble gases is that their configuration, noble gas configuration. Okay? We call this a noble gas configuration. Every time you see that every single shell is maxed out, we say that this element has a noble gas configuration. It has an electronic configuration where everything is maxed out. That's a noble gas configuration. So, noble gas configuration is one where all electron shells are have the maximum number of electrons. That's what noble gas configuration is. This is a very important concept because in the next part of our lessons, we're going to come back to this. Because everyone wants to be nobility, everyone wants to be royalty. All the elements from group 1 to group 17, they want to be just like all these elements here. They want to be nobility. We want to have every single shell filled. How can we achieve that? That is the topic for the next few chapters, or lessons. Yes?
So, group 80 does not necessarily mean the back seat.
Oh, wow. Where's helium? Helium's on the top. Hey, you're right. Okay, so there's one exception. How is right? For helium, you notice the back